Law of conservation of linear momentum. Before going to conservation law, we should know what is isolated system. An isolated system is a thermodynamic system that cannot exchange either energy or matter outside the boundaries of the system. There are two ways in which this may occur. 1. The system may be so distant from another system that it cannot interact with them. 2. The system may be enclosed such that neither energy nor mass may enter or exit. Conservation laws. Conservation law, also called law of conservation, in physics, several principles that state that certain physical properties, i.e., measurable quantities, do not change during time within an isolated physical system. There are 5 conservation laws in classical physics. 1. Conservation of charge. 2. Conservation of energy. 3. Conservation of linear momentum. 4. Conservation of angular momentum. 5. Conservation of mass. Law of conservation of linear momentum. Sir Isaac Newton discovered the law of conservation of momentum. He did this when he formulated his laws of motion. Statement. The law of conservation of linear momentum states that if no external forces act on the system of two colliding objects, then the vector sum of the linear momentum of each body remains constant and is not affected by their mutual interaction. Conservation of linear momentum formula mathematically expresses the momentum of the system remains constant when the net external force is 0. Initial momentum equals final momentum. Pi equals Pf. P equals constant. Let us consider a particle of mass, m, an acceleration, a. Then, from second law of motion in terms of momentum can be written as F equals ma equals m dv by dt, or F equals d by dt m cross v equals dp by dt. Thus, F equals dp by dt. Considering external force on particle equals 0, we have F equals dp by dt equals 0. P equals constant. Deduction of law of conservation of linear momentum for two colliding bodies. Let us consider two bodies of masses m1 and m2 moving in straight line in the same direction with initial velocities u1 and u2. They collide for a short time delta t. After collision, they move with velocities v1 and v2. From second law of motion, force applied by A on B equals rate of change of momentum of B. Fab equals m2 v2 m2 u2 over delta t. Similarly, force applied by B on A equals rate of change of momentum of A. FBA equals m1 v1 m1 u1 over delta t. From Newton's third law of motion, Fab equals FBA, or m2 v2 m2 u2 over delta t equals m1 v1 m1 u1 over delta t. Or, m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. Thank you, and don't forget to subscribe my YouTube channel.